So we left off was the energy of the capacitor. We're almost to the end here. All right, so to find the potential energy or energy stored on a capacitor means that the amount of work you can get out of the thing. And remember, work is your charge times your voltage, or volt times charge. Okay? So if we consider the average potential difference between 0 and F to be V over 2, because this is when charging. So if you're thinking of you're charging a capacitor to 10 volts, you're not always at 10 volts. Sometimes you're at 0 volts. Sometimes you're at 5 volts. Sometimes you're at 7. Sometimes you're at 2. So we can't just use the maximum voltage. It's not always at that amount. So to get the average voltage, it's your half of your maximum. Okay? So to find the work done in charging it to that maximum volt, it's basically the average voltage times the charge is the work done, or the energy stored on it. So it turns out that's just 1/2 QV. And since Q is charge is just your capacitance times your voltage, you could substitute in that and get an extra V out of it in the C. So this is probably the middle one, is the most common one you see on your equation sheets. But these all three, they all work the same way. Okay. They all find the energy stored on a capacitor, this being the most prevalent way, but either of them work just fine. All righty, so here we go. So example number 6, we have a capacitance of 200 volts. We already know, the voltage is 200 volts, the capacitance 11.1, and we're going to put that much charge on there. How much energy would be stored onto there? Well, in this case, we have the capacitance and the voltage, and you just plug stuff in, okay? And there you go. So there's your energy stored. That's the maximum energy you'd have at 200 volts. Now, if you wanted to verify, you could also use one of the other formulas to get the same thing. Okay, because you're actually given your amount of charge that you're putting on there as well. Alrighty. So in summary, so capacitance is a ratio of your charge per volt, measured in farad. But the physical characteristics are how big the air plates are, how close they are to each other, and what do you have in the middle. Okay? And to find that permittivity, the total permittivity, which is your dielectric times your permittivity, you could use a ratio of your capacitance, your voltages, your fields, or your permittivities. That would all work. And badam, there's how you find the energy stored in a capacitor. Done. All right. Have a wonderful time. I'll put a review up shortly of the whole electrostatic section. Oops, there's one more thing we might have to do, is the parallel and series capacitors. All right, talk to you later.